Hello and welcome to section 6.4, which is on properties of rhombuses, rectangles, and squares. So a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. It is also considered a special type of rectangle. A square is always considered a rectangle. A rectangle is only a square if it has four congruent sides. And then the rhombuses can be sometimes a square if they have four congruent sides and four right angles, but they don't always have to be a square. So you got to kind of keep those things in mind. So theorem 6.13, if a parallelogram is a rhombus, then its diagonals are perpendicular. Because it has four congruent sides, if you crisscross from the corners across, they're going to be perpendicular. Theorem 6.14, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Okay, it bisects, so it cuts the angles in half, in other words. So here I have a rhombus. It has four congruent sides, does not have four congruent angles. So my example is, what are the measures of the numbered angles? So I'm going to have to do a little bit of work here. First thing I need to figure out is, how many degrees are there in a rhombus? If you remember from a couple sections ago, to figure out the total number of degrees in any polygon, you take n minus 2 times 180. So there are four sides, so 4 minus 2 is 2, 2 times 180, so there's 360 total degrees in a quadrilateral, okay, in a four-sided figure. So this rhombus has 360 degrees. Then, another thing we can figure out here is that in a rhombus, because there's four congruent sides, that means that opposite angles have to be congruent. So this angle right here, which is 104 degrees, has to be the same as this one over here. So those two are both 104 degrees. So 104 twice is 208. So 208 degrees are already used. Okay? So angle 4 equals 104. And we still need to figure out angles 1, 2, 1, 2, and 3. Let me back up a second. Angle 4 is this little one. In my head, I had it here. It's not there. So you have 104 and 104 here. So we need to figure out how much is left for those other two corners. So 152 degrees is what's left. But that is two angles. That's this whole angle, 3 and 4 together, and 1 and 2 together have to add up to 152. So 152 divided by 2 is 76 degrees. Not 276, it's 76. Okay, so that means that this whole corner right here is 76 degrees. So if I need to figure out, if I use the angle up here, it says, or this rule, it says it bisects the angle. So if this whole thing is 76, then each one, because it's being bisected, is 38 degrees. So these two will both be 38, and these two will both be 38. So angles 1, 2, 3, and 4 are all 38 degree angles. Theorem 6.15, if a parallelogram is a rectangle, then its diagonals are congruent. Okay, diagonals are congruent. My example, if ln equals 4x minus 17, so this whole thing across here, and mo equals 2x plus 13, what are the lengths of the diagonals? Well, I know that they have to be equal to each other. According to this, the diagonals are congruent. So then I could write it out, 4x minus 17 equals 2x plus 13. I'm just going to go ahead and solve this the way that we've been taught. Move the 2x over there, you get 2x add the 17 to get rid of it, move it over here. 2x equals 30, divide by 2, divide by 2, x equals 15. So once I know that x equals 15, I can plug it back in to my original little expression. So 4x minus 17. So 4 times 15 minus 17. 4 times 15 is 60. 60 minus 17 is 43. So 43 is ln. And if I did it correctly, it should work on the other one as well. 2 times 15 plus 13. 2 times 15 is 30. 30 plus 13 is 43. That's a good thing because they have to be equal. So ln and mo, are both 43 across. So we're going to use that information the next time I see you. Have a good night.